for my AP biology class. This is my talk on some of the larger molecules, so for carbohydrates. And as the name implies, um, carbohydrates means carbon water. So your tell of what to look for is that it's a molecule put together with carbon, hydrogen, and oxygen, and it's put together in the ratio of one carbon, two hydrogens, and one oxygen. Roughly, there are a few things that break this rule just a little bit, but it's carbon water. So you're going to see one carbon and then H2O. Now it might be in a multiple of that, so it could be C2H4O2, or when you see us working in a couple of chapters with ribose for nucleic acids, C5H10O5, but that's what you're going to see. So I've drawn them out a couple of ways, and I want you to see how to put them together, and then maybe you can start to piece together about how the other molecules come together and how you bust them apart, okay? So my first drawing here, and I'm sorry that the blue didn't show up as distinct as I wanted to. This is glucose, okay? C6H10O6. H12, my bad. And you can see the ratio here. It's preserved, okay? So 6 carbons, 6 oxygens in red, and I did the hydrogens in blue, and there's 12 of them. And you'll notice that you don't see one carbon attached to one, specifically one oxygen and 2 hydrogens coming off the oxygen. But that ratio in the compound is preserved. Now, sometimes you will see the molecule put together in a ring structure, and a lot of your sugars will be put together in a ring structure. Now, since I'm low tech here, guys, I got to move this down just a little bit. And you're going to notice I did something here. And what I did is I drew 2 rings, okay? Because I want you to see how things came together. And I'm also going to show you a ball and stick model because you're going to be doing a little bit of work with that in a couple of class periods. So here you'll notice it looks different because instead of being in a straight line, the molecule has changed shape, but you still get 1, 2, 3, 4, 5, 6 carbons, 1, 2, 3, 4, 5, 6 oxygens, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 hydrogens, okay? It's still glucose, C6H12O6. Okay, so when you make a macromolecule, it just means, macro means bigger, you're making a bigger molecule. So how would you put 2 of these together? So you'll notice I drew the exact same structure right next to it. So it's the exact same ring, nothing's different about it. So you'd like to be able to link this together. And if you think about it, if you've cooked it all, perhaps you've used starch before. Starch is just a bunch of glucose molecules linked or bonded together. The way you use this in your body is glycogen. It's a whole bunch of glucose molecules that are linked and stored together, and you access this for easy energy, okay? So what you'll notice, oh, well, if you go right here and right here, if you remove an H and an OH and you remove water, well, oxygen, and we went over this at the beginning of the year, can be bonded to 2 things. Well, if you lost water, that carbon could link to that oxygen. You could also do it this way and say, oh, the OH comes off here and you just lose the H. It doesn't matter which way you think about it. You'd still be losing water. What happens then water goes bye-bye. And what you wind up getting, and I got to unplug, is this. Oh, well, now you've got your sugar that's been put together. It's the exact same thing, and they're bonded through one of the oxygens. They're now linked together, and all you had to do was lose water. And now you've got it's not macro yet. We would call this a di, meaning two, di, saccharide, but you've got a bigger sugar. And you've got 12 carbons now. You would normally have, you would have, in the first molecule, you had 12 H's. Well, if you added another 12, that would be 24, but you lost water, so it would be 22. And 06 plus 06, that would be 12, but you're one short, so it's 11. So it would be exactly like adding two together, but just removing a little bit of water. Okay? I want to show you something. What you may see a lot of, and you're going to see this in some worksheets and see this in diagrams, this is a ball and stick diagram, because when we draw these on the board, you see these in 2D, but it's really, everything's in 3D here, okay? So if you look at this, now I'm holding it the way it would be up in the board. And let me just flip this for a sec. Oh, no, I got it right here. So if you look at it, it's hard to draw in 3D, but here's my oxygen, here's my C, C, H, H, OH. So I'm holding it kind of like it would look if it were in real life, but it's in 3D, okay? So I want you to kind of get used to thinking about it. Red, so I can't draw white on the board, it wouldn't show up. So here are your H's that I drew in blue that are white, and here are your carbons. This is how it would look in 3D, okay? Back in a little bit.